Previously, we distinguished between the word metric or measurement and statistics, the field of study. We also tried to look at the differences between rate statistics and counting statistics and their importance in understanding any field that you want to look at. It's very important in baseball to understand the difference between counting stats and rate stats. In the reading for this section, we talked about the two main fields of the study of statistics: descriptive statistics and inferential statistics. Descriptive statistics is the collection, organization, summarization, and representation in graphics of various forms of data. So you want to summarize data sets, collect data sets, and organize them in the right way. Baseball, we've been fortunate enough to have many years of collecting data. And we're going to start looking at these data this week in our BU SQL Sandbox, starting our efforts in this field of descriptive statistics. So maybe looking at the data in the SQL Sandbox will inspire you to ask more questions about baseball. And this is the fundamental piece of being a sabermetrician, being a baseball scientist, is to see data, observe data, consider data, ask new questions, let your natural curiosity drive you to think about more questions you might have, and then try to answer those questions as best you can. So, within descriptive statistics, we're going to cover a lot of things in future modules. One of the things we're going to cover is this idea of measures of central tendency. Measures of central tendency. And a very common one that people have heard of probably before is mean. The mean of a data set. The mean or average of a data set. There's also the concept of the median of a data set, a set of data. There's also the mode, and we'll describe all of these in a future module when we talk about descriptive statistics. These three things are measures of central tendency, and we'll go over those. Another thing we're going to cover in this section of descriptive statistics are measures of the variability of the data set or dispersion of the data set. And these measures of variability of a data set include the standard error of the mean and the standard deviation of the data set. So both of these things will be covered in a future look at descriptive statistics. Another important idea in data science or statistics is exploratory data analysis, or EDA. Now, EDA is what a good scientist, a good data scientist, does. They look at data, they observe data sets, and they use histograms or box plots to help describe their data sets and understand them and summarize them. So a common thing in EDA is using histograms or box plots to describe your data. Another key thing that you like to do with data sets is explore the relationship between two variables. Bivariate analysis, bi meaning two, looking at two variables and trying to analyze them. And typically this is done with something called a scatter plot. Now a scatter plot is just an XY coordinate graph of the two variables under study. So you can look at variable 1 and variable 2 plotted on the different axes. And you can start looking at the relationship between these two variables and to see if, when you look at the data associated with these two variables, if there's any relationship. So I've just plotted a bunch of data points associated with two variables, variables 1 and 2, and now we can start to see if there's any kind of relationship there that might be worth exploring and asking more questions about the relationship between these two variables and why it might be important. That's what bivariate analysis is, and in a future module we'll discuss this much more thoroughly. The correlation, the description of how these two variables might be related. They might be correlated, and they might be correlated either weakly or strongly or not at all. So the whole idea of correlation is a future topic in Sabermetrics 101 when we look at how two variables might be related. But exploratory data analysis is a key step when you have a question about your data set. When you have a question about how two variables might be related, you should start doing bivariate analysis and always start with a scatter plot to see if there's anything you can see in the data set that might cause you to ask more questions and generate more hypotheses. Because that's what a good data scientist is always doing, asking more questions. And we'll try to emphasize this as we go forward in Sabermetrics 101. Another area in the field of statistics that we're going to cover, it's very important to sabermetrics, is regression to the mean. Now, regression to the mean is a concept that you'll see over and over again in the reporting of the game of baseball. It's crucial that baseball analysts have a very clear understanding of this concept of regression to the mean. Regression to the mean. So we'll cover this later in the course. We'll cover it very thoroughly, what exactly regression to the mean is defined as, and why we need to be so aware of it as we study the game of baseball. Now, we'll cover other topics in the field of statistics. But remember, this course here, offered by BU, Sabermetrics 101 on the edX platform, has to cover the key parts of the field of statistics that sabermetricians need. This course is not a full course in statistics. There are plenty of courses offered online through edX covering introductory statistics. And as you go further in sabermetrics, you're going to need to take those courses. You're going to need to advance your knowledge of the field of statistics. So we'll just cover the topics in statistics that are crucial to understanding sabermetrics well, and then we'll go from there. So please do the problem set following this video, and then head over to the BU SQL Sandbox to start really exploring data.